Hello, welcome to 2.5 Part 2. So we're going to pick up where we left off, and it's going to be looking at some other types of functions. Now, the next type of function we're going to take a look at is called a step function. And what a step function is a graph consisting of line segments. Alright, a step function literally will end up looking like steps that you would climb up or down to go into a building. The way that we will see step functions this year is through something called the greatest integer function. And what the greatest integer function is, it looks like that. It's f of x is equal to, and that weird double-ish siding looking bracket. And what it stands for is the greatest integer less than or equal to x. Now, what the greatest integer function is it's a different way of rounding. And the best way to describe the greatest integer function will be to think of this example. So imagine in the service department here at St. X, when you are working for your service hours for campus ministry, imagine if all of a sudden next year they said, hey, we are no longer accepting fractions of hours. You can't do a half hour of service. You must do full hours. So that means if you worked 2.5 hours, you wouldn't round up, obviously, because that would be dishonest for how long you worked. But imagine they said, hey, if you work 2.5 hours, that goes back to 2. The only way to get 3 service hours is to actually work 3 hours, or any length of time of 3 hours up to 3 hours and 59 minutes, to where 3 hours and 59 minutes is still just 3. All right, so this is basically the greatest integer function is the process of not rounding. You are stuck at a number, no matter what decimal follows after it, until you reach the very next integer. All right, and so we're going to take a look at the graph on the backside here to see the greatest integer function in action. All right, so here back on our definitions, I do want us to understand that a greatest integer function is a step function. It will always look like a step function. Now, this last definition isn't necessarily required, but piecewise we saw yesterday are functions that occur in different pieces. We saw some of them. So what a piecewise linear function is saying that, hey, it's a function that still has multiple pieces, but it only contains a single expression. And that's because, when we just graphed this greatest integer function, there was only one function we were graphing, but the graph still had multiple pieces. So that piecewise linear function is basically just kind of a little caveat definition to kind of fill the gap between someone saying, hey, the greatest integer function is in multiple pieces. Why isn't it? Why does it look like a piecewise function? Well, so they drew up another definition that says piecewise linear function. It's a graph that still has multiple pieces, but it all came from one expression. Right? In the example that we just did, it was the greatest integer function of x minus 3. It was just one thing, but the graph still had multiple pieces. So we don't really need to know that one. I just wanted to put that on there in case people were wondering kind of how those all fit together. So one final thing on this, you will notice that I mentioned page numbers. You can check those out in the textbook to see more examples. And then also in the resource section of your textbook app, you can check out videos. They will have some graphs of absolute value functions. They'll have some graphs of doing some greatest integer, some piecewise functions. You'll want to check those out in addition to these notes. So I'm going to make a table to have us look at this, and I'm just going to have us do it through the x values of -2 up through 2. And I already put the subtract 3's there. You'll see that column there in red. And then in that yellow highlighted, I'm going to be substituting in our different x values to see what our y value is. So when we make the table, it's going to seem very plain. But when we graph it, I'm going to show you how the greatest integer function makes a step function. All right, so I'm just going to go through and label out the x coordinates that we are evaluating. and go ahead and evaluate. So the y-coordinate for this one will be -5, -4, -3, -2, and -1. So when you go to plot these points, which I'll go ahead and do, so we have -2, -5, then we have -1, -4, and then we have 0, -3, 1, -2, and 2, -1. Now you might be thinking, Mr. Cottle, that just looks like a line. How is this going to be a step function? Well, that's going to be where the greatest integer portion comes in. The way this is going to look is this. The greatest integer function, so pretend this is us working hours, and imagine in this scenario, this -3 represents you owe 3 hours still. Right, maybe it's now the second quarter. You owe Campus Ministry 3 hours. So any amount of hours that you do for the second service won't start counting until we get rid of the 3. And if they don't let you round up. So here's what it would end up looking like. If you were working this portion, it would stay at that amount until you got right here. So I'm going to put a little open circle there, because this represents when I'm working an hour, it's only counting for that one particular hour until I get to this open circle, and then it becomes the next hour. And this hour would count, so no matter how long I work, it only gives me that 1 hour's credit until I get to the very end, and then it hops up to the next. So this is me working an hour, hour and 15, hour and a half, hour and 45. As soon as I hit the next whole hour, then it jumps up. So you can now see how this would make a step function. And if you look at it, it literally looks like stairs. All right, so after we get this graph, and I'll just continue the pattern on out, we'll talk about how this works. All right, so with us owing Campus Ministry 3 hours, we won't even start to get into the positive until we've worked 4 hours right here. So once I've worked 4 hours, I'm in the positive of a net gain of 1 service hour, but I'm only going to be getting that 1 net gain until I work the entire hour, and then as soon as it switches over to where I've worked 5 hours, then it jumps up to the next rung. So it's like steps or rungs on a ladder, to where it has the exact same value until you jump all the way up to the next process. So all the greatest integer function is basically a function where there's no rounding. So you are stuck at an integer until you get all the way to the next one. So 3.9, you're back to 3. 2.75, you're back to 2. 5.1, you're back to 5. The only time you jump up is when you make it all the way to the next whole integer. Backside to where this was a graph in different pieces. This one had 2 pieces. This one we graphed had 3 pieces.